with my teammates Lance and Shreyas, guided by Professor Shija ma'am, we are here to present to you our project of 3D printer.
So starting with the hardware analysis, we can see here the isometric view. So in this 3D printer, we are using an aluminum body and using 5 stepper motors. So the x-axis stepper motor and z-axis stepper motor is responsible for moving the extruder, and the y-axis stepper motor that is responsible for moving the heat bed. And the last one motor that is used for the extruder that pushes the filament into the extruder. So this is the block diagram. So here you can see the controller block that consists of Arduino Mega and RAM Shield 1.4. And here we have the power supply. For that we are using SMPS. And then we have heat bed and hot end connected with thermistor that collects the temperature data. This is the wiring. As you can see, all the motors, heat bed and power supply is connected to the RAM's shield. So this is the components that we are using. We are using NEMA 17 stepper motor as it is easily available in the market and it is also affordable. And then we are using Arduino Mega 2560 and RAM's 1.4 shield. And for the filament, we can the 3D printer that is capable enough to print with ABS and PLA, but we are using PLA as it is more stiff and strong in nature.
So now coming to the software part of our project, we design a CAD model, but the file saved is in the STL format, which cannot be directly used in 3D printing. Hence, we need some software to convert it into a proper format before printing. This is achieved by the Ultimaker Cura interface, in which the CAD file is loaded and is sliced into various layers, wherein each layer gives the XY coordinates, and the file is known as the G-code file. Also, the parameters such as the strength, opacity, and surface finish can also be configured using this interface. Lastly, a print-ready G-code file is directly loaded in the Pronterface software, through which we can give the basic movement and temperature commands through the interactive tabs. And now the printer is connected to the PC via USB, and the desired 3D printer model is printed. Next. So the software we are using, the first one is the Marlin firmware. The Marlin firmware is the operating system of our 3D printer, which is configured via the Arduino interface. It allows us to configure the RAM's board and also initializes the parameters such as thermal parameters, mechanical parameters, end stop settings, baud rate, and PID settings. This is the Ultimaker Cura interface, which is mainly used to generate a G-code file through the STL format. This is the Pronterface interface, which is used to test and configure the axis and give commands to the 3D printer using the console.
For this project, we had an initial budget of 12,000 and we were able to successfully make this project at 11,500. For conclusion, we were able to design a cost-effective and easy to assemble FDM-based 3D printer model capable of printing a 20 by 20 by 20 centimeter object. It is compact and was capable of printing complex designs while being more efficient than traditional manufacturing methods. This allowed us to speed up the prototyping phase and reduce the wastage of materials, thus making the overall project more cost-effective and environmental friendly. Future research into this project will allow us to add a 3D scanner that can be attached to it. This will allow the people to scan an object and print 3D copies of it directly. One could also change the filament and convert it into a PCB etching machine. As for the scope of the 3D printer industry, because of its wide application in prototyping and testing, it is supposed to pave the way for the Industry 4.0. Here is our final design for our project. Here is a short video of our project in action. is the final output that we were able to make using our project. Thank you.